System Architecture 1.1 Recap. So working clockwise round then, CPU, the Central Processing Unit, what's the purpose of it? It processes all data and instructions to make the system work. It carries out the fetch, decode, execute cycle. So just think about data and instructions. Your go-to word in computer science is data. Stores data. It processes data. So it processes all data and instructions. The fetch, decode, execute cycle, simplified. An instruction is fetched from memory. The instruction is then decoded. The decoded instruction is then executed, and this process is repeated over and over and over again. So you fetch it, you look at what it is, and then what do you do with it? Similar to the activity we did in class. CPU performance. There's three main things that can affect a computer to make it faster. The clock speed is the number of instructions that are carried out per second. So how many times can it do the fetch, decode, execute cycle a second? The number of cores. Each core independently processes data or instructions. So the more cores you've got, the more independent instructions that can be carried out. It's not more instructions, the key word is independent, because they can think on their own, like having two heads that can think on their own. And cache size. Faster to access than RAM. Okay, it takes further to go to RAM than it does to go to cache. So if the instructions are in the cache, right next to the CPU, and you can store lots of instructions in there, it's faster because you haven't got to go looking anywhere else. A register, what's the definition of register? Is a component for short-term memory. What's an embedded system? Computer systems built into another device. And you should be able to recite three of these, at least three, with a predefined function. So if it was me, I'd be thinking about a kitchen and a microwave, a dishwasher, a washing machine, those sorts of things. Common CPU components then. So what's commonly in a CPU? We've got the ALU, the arithmetic logic unit, that does all the calculations, arithmetic. The CU, which is the control unit, that does the decoding and the executing of instructions. And cache, very fast memory, stores regularly used data, it's got low capacity and expensive. Otherwise we just have a massive cache, we wouldn't need RAM and we wouldn't need anything else, we'd just store everything in cache. Because it's so expensive, we can't do that. The von Neumann architecture basically is a theoretical design of what a CPU should be. And you've got the MAR, the memory address register, the memory data register, a program counter, and the accumulator. So the address register is like the number, like the house number, 1 through to 20. The data is what's in that house at that address. And the program counter tells you what current instruction you're on at that moment in time. The accumulator stores the result of the calculations of the ALU. So let's say it takes from memory address box 1 and memory address box 2, and inside those boxes were two numbers we want to add together. We add them together, and then the result of that is stored in the accumulator.